Welcome everyone to our CI Compass webinar. We have three guest speakers today: Shava Smallen, who's the PI of CloudBank2, Rob Fatland, who's is on the support team at CloudBank, and Eric Van Dusen, who runs the student activities at CloudBank. And I'm going to go ahead and hand it over to you guys to get started. Thank you very much.
Yeah, thank you so much for giving us an opportunity to speak to this group. We really appreciate it. So yeah, my name is Shava Smallen. I'm the PI of the new CloudBank2 award, which was announced by NSF in April. And essentially, we are a new services-based resource that will be offered through the NSF Access program. And our goal is designed to streamline and democratize access to commercial cloud resources for the science and engineering community. We are a partnership between UCSD, University of Washington, and UC Berkeley. So we've got representatives from everyone here today. So I'm going to start off with a brief overview of the CloudBank project, which started as an NSF pilot project. And then I'll talk about our transition to CloudBank2 and some of the new features that will be provided. And then I'll hand off next to Rob Fatland from University of Washington, who will speak a little bit more about some of our experiences with CloudBank support. And then Eric Van Dusen from UC Berkeley will wrap up with some updates on the classroom tools that are provided through our education hub. And then we're happy to take any questions you all may have for us. So I wanted to start off with a brief summary slide of how we think we can help the CI Compass community. We really appreciated the report that you all put out last year. It really resonated with us. Really agree with the idea that a cloud adoption is a measured process. We are here to facilitate commercial cloud adoption, but we realize, the value as well of on-prem resources. And so we definitely agree with the commercial cloud adoption as being a kind of a case-by-case decision. Some cases commercial cloud will be appropriate, in other cases it won't. And you can mix and match and have used both resources together. So yeah, it was a really excellent report. Thank you for everyone who worked on it. It was really, really good. And so how we think we can fit into your processes is, again, we are here to facilitate a commercial cloud integration. Will be offered through the NSF Access program. So as you are maybe exploring commercial cloud resources, please think of CloudBank as a resource for you. There's the Explore and Discover allocations that we think will be appropriate for development or pilot projects. And so I'll have a slide a little bit later on some of our allocation plans for access. But at the end of the day, we also have some discretionary allocations for some more of the unique use cases that may pop up and may not fit in neatly to one of the access categories. But yeah, we are here for some of that exploration that you may be wanting to do in your project. And then second of all, we know there's a lot of people on this call that have a good deal of commercial cloud experience already. And, we have been primarily focused on the computer science community, but we will, as we expand out to the larger science and engineering community that's served by Access, we would love to capture some of your research workflows to share with our coming users, and we're happy to share any lessons learned that we have as well. And down the road, if there's some training topics that you might be interested in, we'd love to help out with that as well. So next, I'll just transition and tell you a little bit about how we got started. So there was a NSF solicitation that was released back in 2018 for a cloud access identity, and we were one of the applicants. And we were working on the CloudBank proposal. We interviewed SCI's researchers at our home institute to find out, what types of pain points they were encountering. And the quotes on this slide are from some of the researchers that we interviewed that kind of capture three main areas of friction. The first is just getting account access and configuring billing. The second are general getting started questions. And then the third is monitoring and managing costs. And so these are the three areas that we really focused on with CloudBank. We started in August of 2019. Our goal, again, is to facilitate researcher access to commercial cloud resources focused initially primarily on the computer science community. Essentially, we function as a bank where we receive funds from NSF and then broker out the commercial cloud access to the researchers. We currently support Amazon Web Services, Google Cloud, Microsoft Azure, and IBM Cloud. And essentially, we take care of the administrative and financial details, so you never have to put down a credit card or anything like that. We do that with a user portal that manages the account creation and access so that researchers can get onboarded quickly to the commercial cloud. Then we help them monitor and track their spend. We have the financial services, which take care of paying the bills every month, so the researcher never has to worry about that. And then we have a help desk, training materials, and webinars to offer for researchers. One important aspect of CloudBank is that once you're onboarded to CloudBank, you can use any of the public commercial clouds that we provide. So basically, as you spend, we track that spend and then we just deduct it from your allocation. And on the bottom, I just have some quick stats on the number of awards and cloud accounts and the number of institutes that we've supported with these awards. So just a quick walkthrough of the CloudBank portal. This is the screen that you would see if you log into the CloudBank portal with your home institute credentials. On the left is the kind of PI dashboard where PI can monitor the balances of their cash, which is traditionally what we use, but we do also accept vendor credits, which is actually how NAIR Pilot is allocated, and I'll talk more about that in a bit. The PI can then create accounts in the different cloud vendors that we have access to, and then they can share that access with their collaborators. In that middle square is where any of the researchers can come in to see what access to cloud accounts they have. And then from there, they can jump directly into the Cloud Vendor Console using federated login, which is enabled through the CI logon tool. And then the last square is where a researcher can kind of dig into more details to see more information about how they're spending. And here we use a third-party cost monitoring tool called Nutanix Beam. We also offer an education hub, which is based on the Berkeley data stack, which was developed at UC Berkeley to manage large classes, especially a very popular data science course. So it's a scalable Kubernetes-based Jupyter hub that provides auto-grading tools and other classroom tools to help manage classes in the cloud. And to date, we've supported a number of community colleges, state universities, and a few HBCUs. And Eric will give you more details about that later in the talk. So as far as what our researchers have been doing to date, we have been focused primarily, again, on computer science researchers. And one of the use cases that we've seen is for cloud bursting or scaling experiments. So these are researchers who are developing tools and want to be able to verify or validate the scalability of those tools. And the commercial cloud makes that easy to do. Likewise, anyone who's doing network research can easily spin up VMs in multiple areas of the world if they're interested in studying global or regional network behaviors. A more unique use case was that of chip design. We had a researcher who needed access to tools from TSMC and Cadence, and commercial cloud was how the vendors wanted to distribute those tools and give the researcher access. And so CloudBank was used to facilitate that use case. Another area is in quantum computing. A few years ago, there was a Dear Colleague letter that NSF put out, and as a result, we got about 8 projects that were interested in using quantum computers. And so these are one of the more unique resources that we can bring to the Access portfolio. And then AI is probably our most popular use case. So sometimes researchers just want access to GPUs, and other times they want access to some of the higher level services that are available through like AWS SageMaker or Azure's OpenAI or AI Foundry. And then the last main use case that we've seen is in edge computing, so using commercial cloud resources to process and receive data from edge or IoT devices. So where we are today, we are in the 6th year of our pilot project. So we got a little bit of a bonus year to give us time to apply to the ACSS program, which is traditionally used to fund on-prem resources, but was expanded to enable services-based resources such as ours. This is a Category 1 award, so it's $20 million over 5 years. And the biggest change is that it will enable us to go beyond the computer science community to serve the broader science and engineering community that Access currently serves, and NAIR pilot as well. And we actually are already part of the NAIR pilot, and I'll talk a little bit more about that in a bit. We do officially start on August 1st next month, and plan to be operational in Access by December. So this is a quick overview of the CloudBank2 architecture. Again, one of the main differences is that we'll be allocated through Access. So we'll be able to provide the explore, discover, and accelerate allocation levels. And I'll talk a little bit more about that in a bit. And then on the right are kind of the managed services and support that we'll provide as CloudBank2, which builds off of the services that we built for CloudBank1. And so I'll just dig into a little bit more detail on some of these blue items here. There's some of the new features that will be provided. The first is some support for regulated projects that require access to regulated data. Here we're partnering with a group at SDSC called Sherlock, which has many years of experience of working with regulated data. So we'll provide some amount of support for these types of projects. The second is some enhanced support for our education hub to better support AI education. And Eric will talk a little bit more about that in a bit. We also plan to provide some enhanced API support to enable science gateways and community tools to take advantage of the commercial cloud. We've had one request, to be able to use API to create accounts, for example. Another enhancement is that we plan to facilitate data transfer by deploying Globus endpoints into the commercial cloud. So that'll make it easier to transfer data between Access resources and/or your home institute. We also want to be agile and be able to adapt with the market and enable new cloud vendors when it makes sense. Voltage Park is a new cloud vendor that just became part of the NAIR pilot, and we hadn't even heard about it, up to a few months ago, and now we do. And since they're made a big contribution to the NAIR pilot, we will plan to integrate them into Access as well. And NVIDIA DGX Cloud is also another partner that participated in their pilot and was really highly used as well. And then the last enhancement I'll mention is that we plan to upgrade from Nutanix Beam to a new cost monitoring tool called Kion, which will allow us to better scale our operations. This is an overview of our allocation plan. We planned to kind of allocate out that 20 million evenly, about 4 million a year, and hope to support about 500 projects per year. These are the different Access allocation levels. We plan to kind of allocate heavily towards Explore to help make that 500 number. So the Explore level starts between 0 to 10K, and we hope will account for about 85% of the projects we support. This discover is the next category up, might be a smaller amount, about 13%, and then the smallest amount would be the accelerate category, about 1%, but would be the largest category, who asked for about 75K per year. We weren't planning to support the maximize category solely, but we could be part of somebody else's maximize allocation where they're requesting multiple resources. And then again, anything that just doesn't quite fit cleanly under these categories, we would have some discretionary funds that we could provide for some unique situations and other scenarios. And if you're not familiar with the access allocation process, I have a picture of the workflow on the left-hand side here. So basically, you create an access account, you apply for one of those allocation levels, you decide how much resources you want to use and which types. You submit the request, it gets reviewed, and then when it's awarded, you get your allocation in credits, and then those credits can be exchanged on access resources. So CloudBank Research and CloudBank Classroom will be listed as resources that you can request, and then when those requests are granted, then you get your resources. So again, the biggest thing is that we're now available to any US-based researcher. And when you submit your exchange request, we would just ask that you submit a cloud vendor calculator URL with your cost estimate, just so that we can make sure that you're going to have enough resources for the project that you want to do. And if you're not sure what you need, you can always reach out to us at help@cloudbank.org, and we can do like a 30-minute call with you to get a better understanding of your use case. As I mentioned, we are already part of the NAIR pilot, and if you're not familiar with that, it's like Access but focused on AI. It has a number of the same partners, but it also has a number of commercial cloud resources that have donated credits to the NAIR pilot. And so we are helping to shepherd the cloud vendor donations for AWS, Google, Azure, and that new vendor I mentioned, Volta Park. I would say the main difference between this and Access is the NAIR pilot it's a 2-year pilot, and we're now in year 2. And the allocations are restricted to US-based researchers, whereas for Access, only the PI needs to be US-based. And then the allocation is awarded in vendor credits, so you are kind of tied to that cloud vendor unless you request a change of some sort. So we are currently managing about 116 NAIR awards, which is roughly about, I think, a quarter of the NAIR awards that are awarded today. And since we're in the second year of the project, some of the cloud vendors are starting to kind of tap out on their allocations. So AWS and Google have paused allocations at the moment, but Azure and Voltage Park are still accepting new requests. So if you're interested, please go to the nairpilot.org website. And if you have any questions, you can reach out to us at help@cloudbank.org. And I'll mention too that the Azure credit donation runs out on June 30th, 2026. So if you're interested in using Azure, please apply early so that you can have the most time to use that allocation. So with that, again, we're very excited to speak with you today and hope it's maybe just a first start of a conversation. I did want to mention that we are looking for researchers to participate in early user operations, which we hope will begin in like a September, October timeframe. So if that's of interest of you, please let us know. And in any help you can give to get the word out about CloudBank2, if somebody's doing some development or pilot project, please think about CloudBank. We're also looking for a regulated data management use case to try out our pilot in early 2026. And we encourage you to participate and share any of our CloudBank events. We have office hours and cloud clinics that you can sign up for on our cloudbank.org website. And with that, I think I will go ahead and hand off next to Rob.
Great. Am I audible?
Yeah, you're good.
Okay, great. Thank you. So looking at the CI Compass survey document, I'm just quoting here that the recognized cloud benefits are include reliability, scalability, on demand, of course, and storage, with barriers including cost and funding, those related topics, and then the complexity of translating a CI to the cloud, and then, of course, skill gaps. So hopefully I'll talk about this some in describing the education outreach training component of CloudBank and CloudBank2. And so the way that I tend to think about it is that the cloud technical component is where our element of CloudBank is trying to come in and provide support. And this is both in terms of efficient cloud use and then developing the skills that we'd like to talk about. And skills typically are kind of in a bimodal distribution. There's the research team that just needs virtual machines and maybe a GPU and they're good to go. And then there's sort of a deeper investment into the cloud stack. And that's a sort of a second mode of adoption of cloud. Let's move to the next slide. So from our experience in CloudBank, we're kind of suggesting that removing the cost barrier initially is a great way of getting that kind of clutter out of the way and being able to focus on skills. So that's primarily what I'm going to talk about. And this idea of getting rid of that certainly comes into play when there's let's say, a research team trying to evaluate where they should build their CI. And on paper, the cloud looks like a good idea, but there's this learning curve in the way. And so in order to really make an effective pathway for the researcher, you have to coordinate them with the vendors, as Shava's been describing, for example, in NAIR and with the funding agencies. And so both NAIR through the cloud credit allocations and then CloudBank version 1 for its 6-year history, which is just winding up now as we transition into CloudBank2. We have had various ways of eliminating the $ from the equation and determine if the cloud is right for somebody based on getting through that skill learning curve. One interesting thing about CloudBank's first 6 years is that we tended to find a group would get allocated so many dollars, but considered across many different research teams, typically about 1/3 of that allocated resource would be unused, would go unused. And so then the question is, well, why is that? If you've got this, $20,000 in cloud, why are you not spending it all? And part of that is because delays just happen in research. People kind of don't get to the thing they were hoping to get to in the time frame. And then there's also the real skill gap and perceived skill gap. But also cloud cost estimates can run high. It's easy to overestimate how much the cloud will cost you. So I'll touch on that a little bit in what I'm presenting here. Cloud skill development is really the center of the issue, and traditionally IT cloud pros, I found out when I started in this area about 10 years ago, like to use the phrase cattle, not pets. And that means treat the cloud resources not as something that you personalize and identify with, like maybe we do with our laptop, but rather as just sort of this, disembodied kind of abstracted thing. The problem with that is that, we put background screens on our computers because they are sort of like an important part that can be connected to identity in some sense. And so when you start to talk about the cloud, it seems like an unfamiliar place to go and do your computing. But fortunately, the cloud providers are regularly building sort of familiar abstractions. So that kind of helps bridge the gap between where we're used to being in our computing and where we need to go if we're going to be effective on the cloud. So my little call to action bullet down here in this overview slide is that self-documenting, in other words, documenting what we're doing as we figure things out is really an important skill to encourage research teams to adopt. And then I'm going to try and talk about building domain-specific communities on cloud infrastructure as a way of kind of immersing the cloud in the background and making participation in the scientific process for the research teams be something that's not just limited to a small group, but can actually start to build a community and the advantages that has. And I will cite the Vera Rubin Observatory as an MF that's encouraging participation along these lines. So let's go to the next slide. Okay, so I have three remarks. The first remark, in short, is that there's a researcher here at the University of Washington, where I am, named Maureen Denal, and her research team recently ran a $100,000 cloud computing job that actually cost $19,000. And that's because she has a graduate student who can take the time and has the skills to learn how to use preemptible spot instances on the AWS cloud. This is in conjunction with a facility called EarthScope, or it's an organization called EarthScope around seismic data. Let's see the next slide. It's a more detailed version of this. So this is the scale of the processing run is 65,000 seismic stations running for 24 years at 40 hertz sampling rate. So there's a lot of data. And the idea is to identify seismic event arrivals at these various stations and turn that into a catalog. This is on AWS with 12,000 vCPUs, and it took a weekend. And as I say, the spend was drastically reduced. So this is a great success story. And it also incorporates the containerization technology. So let's go to the next slide. So my point of remark one here is that there's this trade-off, as we can imagine, in taking the time to learn and implement things like checkpointing to make the cheap instances of the spot market accessible. And then you suddenly have this factor of 5 increase in your compute capacity on the cloud, which is getting back to my earlier point about how it's easy to overestimate the cost of computing on the cloud. So let's see. Yeah, so this together with secure practices amounts to cloud efficiency, the sort of part of the equation that I referred to at the beginning. And we ultimately want to be spending $1 for $1 of cloud compute. Okay, let's go on. So remark 2, I'd like to tell you what I find to be an amusing story. So there's some advanced work that goes on ahead of this story starting, and then the black text is what the user types into their computer, and the blue is what the computer comes back with. So everybody likes to get into code. This is some Python code using the bash shell exclam at the beginning. And all we're doing here in the first line is, in our little story, is asking the computer what's in the directory moles, the data directory, and starts with moles, and there's 3 files there. It looks like there are 3 years in a row. And so then the next, that's the blue. Then the third line is the programmer again says ds equals, and then open data set. So all you're doing here is opening up the data set, moles 2021, that's in that data drive folder. So far, so good. There's nothing unusual going here. But if you suddenly think to yourself, I wonder what the capacity is on my drive, then I can use the Linux disk-free or df command. So I say in the next line of code, df tilde data. And what comes back from the computer is a file system called mount.point S3, which has 9 exabytes of data available for use. And that's actually not a typo. That's actually really what happens. And the punchline of this is that what I've done in advance before this story started is I used the abstractions that are built by the cloud vendors to mount an S3 bucket on my laptop. So in other words, the laptop folder data looks like an ordinary directory with some data files in it, but I've actually mounted it from the cloud. And what's cool about this is that the behavior that I need to have after I've done this is what I've always been doing. It's the familiar sort of in the pets domain rather than in the cattle domain. It's an abstraction that makes it easier for me to use the cloud without having to worry about URLs and endpoints and ACLs and all this other kind of technical stuff. So it's kind of the favoring the user rather than the CI builder frame of mind. Let's go to the next slide. Okay, so for 2.3 cents per gigabyte per month, my data in a cloud bucket looks like a drive on my laptop with 9 exabytes of capacity. And this is a slightly limited version of POSIX, but it's still very useful. Another example from the PETS frame of mind is to configure a cloud virtual machine as one's personal workstation. You can do that using SSH tunnel. So again, it's showing up on your laptop, even though you're logged into virtual machine on the cloud, and you can scale those virtual machines up and down as you like using images. And for peace of mind, you can use an access control system like Git and GitHub to make sure that if something goes goofy sideways on the cloud, you can still keep working by just simply pulling it back off of GitHub. So there's this task of creating a translational fabric of where we compute today to using the cloud. And who builds this? Well, the developers in the first place are building these, pet-like abstractions. But then we have motivated faculty and students. And then finally, I want to call out IT pros at our various academic institutions who are granted a little bit of headroom to go and learn this stuff. Next slide. So again, this is remark 3 of 3 remarks that sort of come out of my work with CloudBank and here at the University of Washington on cloud advocacy. And here I want to talk about community building a little bit with the simple idea of using git clone to copy a repository and then open up a Jupyter notebook. And there's a cell with just 2 lines of code in it. The first is an import, and then the second one is an equals, an assignment using a OC method that creates a chart. So with 2 lines of code, I can run these 2 lines of code, and out of the box, straight out of git clone, I will generate this chart that I'm showing here, which happens to be some oceanographic data. That's salinity and temperature with depth. And the nice thing about that chart is that you're like immediately drawn into, well, what does it mean? What does the structure of this data mean? And you can sort of start to get back to the whole reason you got into research in the first place, which is it's fun to look at data and try and figure out what it's trying to tell you. So this is my point. Creating a repository like this that out of the box does something in 2 lines of code is a way of sort of communicating to our user community, our researchers, that there's not a lot of complexity that they have to master. They can use something that's already been sort of pre-built, and if that's engaging and that is sort of fun to work with, then some people are going to look under the hood and say, oh, here's the code in this module file, and they'll sort of start to pursue this, and it's much easier to go up a learning curve, including a cloud learning curve, when you're enthusiastic and you can see kind of the point of it all. So that's what we're kind of trying to advocate, is this in community building, for example, in oceanography. So demystifying the cloud, and this, of course, aids us in collaboration. And then I'll mention also that organizations like Hugging Face and AI2 and Internet2 and are resources for doing quantum computing and containerization and source code control. It's all part of this sort of open science culture. And that's kind of like what we like to wave the banner for. Next slide. Let's see. So the last thing I'll mention here to wrap up then is that my segment is that CloudBank does technical consulting, and our baseline approach to this is that we like to help evaluate the question of whether or not cloud is available. And Bob asked this nice question about Jetstream. We do try and be very, very even-handed across the cloud platforms and across other possibilities, other directions to go, like Jetstream, where we really would just want the researcher to find the best path for them. We have Cloud 101 resources. We have a community website. We have lots and lots of operational support from Shava and the UCSD team. And then we have some technical consulting ability. We can connect people to liaison. We can liaison to vendors, set up workshops. We do office hours. We do cloud clinics. And we can, let's say, take some, I need to do this statement by a researcher and turn that into a demonstrator of an underlying technology. But we can't jump into a project and start building stuff. And this leads to the final remark here that functional cloud CI is ultimately the PI's responsibility. And so that's how we're looking at it. Next slide. With one little asterisk here, which is related to the Access Match program. So as I mentioned, I'm at the University of Washington. I'm at the eScience Institute. And within that institute, there is a group called the Scientific Software Engineering Center that's currently exploring community building with the Vera Rubin Observatory. And the idea is to encourage people to bring their cloud computing credits to where the data is. So this is a prototype science gateway engagement, and it has potential integration with Access Match. So that's an interesting opportunity. Next slide. And this is just sort of a case study where I wanted to read out loud the bottom remark. AWS EC2 GPUs provided a huge convenience for this research. The AWS cloud was easy to use, stable, and dramatically accelerated model training. This is from a CloudBank group report, progress report. And what's great about it is you can see the cloud fading away. Like these guys can get back to focusing on their robotic vision. They don't think about Cloud CI anymore because it's just there and it works. So yay. Next slide. So before I turn it over to Eric, again, we're advocating, we are on this journey of personal learning so that we can do cloud advocacy from an informed perspective. And then we're waving that open science flag plus the documentation flag. Yeah, let's do that stuff. And as Shava mentioned, each cloud has its AI machine learning stack, and this is expanding the cloud, the scope of what we need to understand and know about and be able to advocate for. So that's everything I got, and I'll turn it over to Eric. Thank you so much.
Hi, everyone. I'm like your step cousin over on the teaching side, but we're all at universities. So I'm going to tell a story about using cloud for scaling teaching. So UC Berkeley has a new college, computing, data science, and society. They got the biggest major at UC Berkeley is now data science. They got the biggest class at the lower division at UC Berkeley, intro to data science, and they got the biggest upper division class, data 100. So some of this slide is like, what is it like to teach students that are going to be part of like an AI workforce? And I was like, we could think of it as like a progression of learning these Python packages. You're a freshman, you learn NumPy. Sophomore, junior, you learn pandas and SQL. Senior, you're learning scikit-learn and PyTorch, and you're like progressing through those. That was just an example of thinking about how we need to get these tools into the students' hands. Next slide. So some of the big classes here, like these are classes that are taught at a huge scale, 1,500 people in data 8, 1,000 people in data 100, right? So, and these classes are like a suite of Jupyter notebooks, like the work that the students do, the place where the learning happens, the textbook itself is made out of Jupyter notebooks. And all of these are happening on a cloud-based server. So basically the only way we could get to like teaching these huge number of students is using this cloud-based server for making like ubiquitous availability of the interactive computing where all the work is going on. The far right column is my class where I teach, so I'm like over in economics, teaching students like a domain application using these same Python tooling, Jupyter Lab interactive computing, but sort of following on this pattern to make like a domain class that's based on a Jupyter framework using the Jupyter Hub, but out there. And this is part of my vision too, is like, how can we bring other faculty on to teaching in this interactive computing way? So next slide. So some of my experience has been from working in like past 7 years on how to do this. Like this is making a tiny little bit of virtual machine available to thousands of users. We're like 5,000 users a week, 10,000 users a semester. Everyone at Berkeley can log on. It's accessible. Any machine can run. It's a full open source stack, so there's no licenses. We can deploy it in the classroom. Students can do it wherever and whenever they need to. Most importantly, the students don't need to set anything up. Like the environment is right, the files are there, and that's jumping over a lot of the hoops and from local install and getting the files in the right place. I also think it's this, Rob just did a few shout outs for like open science and reproducible science. The classes are sort of run like experiments in open science and reproducible science. And that sort of brings interesting elements. The students are learning these open science principles without actually knowing that they're being taught them, and they're being taught sort of like an open source software way as they go. So next slide, please. So here's my map of like what we're doing, and a lot of what I do is this sort of on the instructor side, like assuming that CloudBank2 can put together a Kubernetes-based Jupyter Hub that we can make accessible to other universities. And then it's like working with those instructors, professional development classes, documentation, giving them some familiarity with a sort of interlocking set of open source software that allows them to teach on the cloud. And what does it take to do that last mile where you're like reaching out to instructors, finding instructors who are familiar, comfortable already, or finding instructors that are ready to make the jump and learn some of this like cloud-based teaching workflow. And it's also sort of an interesting time where like we're not just making Jupyter notebooks available anymore. It could be an RStudio instant, could be VS Code. It's a way to make a tiny sliver of computing that's scalable, that could access big data or GPU if needed. But it's like how to make that small amount of compute available to everybody, given like a single university-wide authentication. So next slide. So some of this is like, we did this at UC Berkeley. We have this experience of a lot of the toolings built out, like, the workflow of teaching. And then previously in my career, I was doing sort of like outreach to other types of faculty. Hey, earthquakes faculty. Hey, astro faculty, like come teach work with, this interactive computing in the classroom. The physics department started to redo their curriculum based on like physics students having like base knowledge of this tool set at the intro physics class, and then the upper division physics class could do things. Social science classes all have like statistics, public health, economics, they all have this, and how can the cloud-based computing like solve their problems for getting students through that. So what have we been doing with CloudBank for the first 5 years? It's like, how do we do this outreach to institutions that aren't our ones, right? Like, the UC Berkeley can afford to be out in front, and most of the institutions that you folks are at are probably have some offering in this way. But what is it like to make this interactive computing platform work for resource constrained teaching institutions, community colleges, MSIs? And we have slowly built out like the platform that we can serve and onboard teachers from these other institutions as we go. So CloudBank2, we're looking to scale that up and find partners, and keep scaling nationally, and people who are interested in teaching with interactive computing. Next slide. One more that I just wanted to shout out. So we were with a partner, a nonprofit, 2i2c, who's working in this space, and we've worked with them for years on the educational space, and they're our partner in scaling out. But I also wanted to shout out that they do some, workshop hubs. So suppose you have a big instrument, a big data set, and this is, they had a bunch of presentations at AGU last December. And I think Rob had talked about EarthScope. There's also a big collaboration with NASA. This is where like they create an ephemeral Jupyter Hub for an event or like a hackathon, connect it to the big data source, the NASA data set, or like the big geoscience data sets, and then give faculty who are attending or researchers or grad students who are attending an easy on-ramp to jump on, and then give them like a collaborative experience in touching, these research tools in the cloud. I have worked with this a lot in the educational space. So I just finished a workshop where we bring in educators and we make one of these ephemeral hubs so that like I'm in a room with 50 or 75 educators. Everybody can jump on and experience like teaching a lab with interactive compute while we're there. And so like the professional development of getting people to use the tools, this is sort of like a more complete front end for doing that in sort of that workshop training space. I think that's it for me. Happy to follow up with anybody and or answer questions in the side.
I just wanted to close with this last slide with our URL and our help email. If you have any follow-ups, we've been trying to answer your questions in the chat. Thank you so much for your interest. And I just wanted to put a few URLs. The community forum is kind of where we post some of our commonly asked questions. That could be a resource for this community as well. And I'm putting the schedule for our next cloud clinics and office hours. If that interests you, you can sign up on the cloudbank.org news to get notified when we post new webinars.
Please, everybody, join me in thanking our speakers for a great talk. Thank you very much, Shava, Eric, and Rob.
Yeah, thank you so much for the opportunity.